Hello students, we'll be reviewing practical 2 which you have done last week. This is on redox titration. That means that it involves oxidation of reduction. So in this case, permanganate will oxidize iron 2 to iron 3 and itself gets reduced to manganese 2. Okay, so if you recall, we have Fa1 which is a very dark purple solid which you have to weigh out using the electronic weighing balance. And you have Fa3. So Fa3 is a near colorless solution. It's actually pale green in color. I mentioned that avoid getting iron 2 onto your shirt or your pants or your skirts, because iron 2 will be easily oxidized by the oxygen in the air to orange iron 3. Yeah, so if that happens, you will see patches of iron 3 on your shirts. Yep, and then Fa4 is sulfuric acid. Do take note that for this particular permanganate iron 2 titration, you need to ensure that your aqueous solution have excess acid. Yeah. If not, you're going to end up with brown PPT of manganese 4 oxide being produced. How do you know that? Some of you might notice that if you leave your solution there for a period of time, you will start to see brown PPT appearing. Yeah, so that is one of the reasons why the solution has to be acidified. And of course, you are also advised to wash your conical flask immediately after the titration, because the manganese 4 oxide can stain quite stubbornly onto the side of the glassware. Okay, yeah, then you are given the balance equation over here. So take note of the stoichiometric ratio, that is 5:1. Yeah, and do note that your acid is in excess. If it's not in excess, you will probably end up with manganese 4 oxide being produced instead of manganese 2. Yep, and you are given this very important statement which will give you the answer to one of your question later on. I think that is part F. Okay, sulfuric acid is used as the acidic medium, to provide the acidic medium. Nitric acid might not be suitable as it is oxidizing in nature. So nitric acid, if it's concentrated enough, it might oxidize iron 2 to iron 3 as well. Hydrochloric acid is not suitable in this case because the chloride anion will be oxidized by permanganate to give you chlorine gas. As to the exact reason why that is the case, you will explore more about that in JC2 or maybe towards the end of JC1. Yeah, so not to worry too much, because there is something known as the standard potential or standard cell potential, which you can calculate to determine whether the reaction between A and B is thermodynamically feasible. Yeah, but that is not something which you are required to do now, so not to worry about that. Okay, yeah, then the preparation of Fa2 from Fa1 is relatively straightforward. That is something which you have done before in practical 1, except that in practical 1 you are simply diluting a solution, a concentrated solution of hydrochloric acid, if you remember that. Yeah, but in our case here, we are using the electronic weighing balance. Yeah, so do take note that when you are using the electronic weighing balance, if you accidentally spill some solid onto the weighing pans, right, please use the brush provided at the side to remove them. Yeah, because if you do not remove them immediately, it might absorb moisture from the air, and then eventually it will form a partially hydrated salts, and then it might corrode the pan. Okay, so it will help a lot if you could use the brush to remove them. Yeah, and then in the question or in the lab procedure, you are told to weigh accurately about 0.50 gram of Fa1. Do take note that whenever we write 0.50 gram, the range which is acceptable is 0.45 all the way to 0.54 gram. Yeah, so this is the range accepted. Yeah, so if you read through the whole procedure, right, you do not need to wash the remaining solid in your weighing bottle into the solution. Yeah, so if you weigh about 0.5, you try to pour as much in as possible, you will probably end up with about 0.49 or 0.48 grams being transferred. Yeah, so it is still well within the range. You do not need to worry too much whether you transfer all the solids. Yeah, and then requirement is to record all weighings, appropriate level of precision. Okay, yeah, so if you read through everything, you're supposed to transfer the weight sample, and then after that use deionized water. Some of you still end up with squeezing the deionized water from the bottle itself. You can actually uncap it and then just pour some of the deionized water in, not to worry. But do take note that potassium permanganate solution tends to jump out of the solution quite readily. Yeah, so it will tend to spill out. So just be very careful when you are diluting it. Okay, and because the purple is very intense, right, you will need to use your glass rods to actually crush the solid sample thoroughly before you pour them into the standard flask. Okay, the standard flask is also known as the volumetric flask, so do take note of the terms being used interchangeably. Yep, and then you top up with deionized water. Add the last few drops using a dropping pipette. That is also what we call a dropper. Yep. Do take note that you need to observe how to read off from the marking. Usually for intense colored solutions such as potassium permanganate, you will read above the meniscus, but it is actually possible for you to read off without swirling first. Yeah, because the last few drops, the portion at the neck of the volumetric flask tends to be very diluted, so you can actually read off the markings quite accurately. Okay, and then make sure you swirl them to get a homogeneous mixture, and do ensure that to cap the volumetric flask back whenever you pour it into the burette. I think you need to pour this into the burette later on. And then later on, if you need to top up your burettes, just make sure that you always swirl them first before you pour them into the burette. Yeah, these are all the good practices which you need to follow. Yeah, and then you will label this solution as Fa2. Yeah, and then you reweigh it, and then it may contain residual Fa1. So this is a requirement. So you need to reweigh it. You do not need to transfer all the solid into the beaker in step 2. You transfer as much as possible. If you do not wish to do the reweighing part, let's say you want to transfer as much solid as you want, you could actually in step 2, right, add a little bit of deionized water to get most, if not all, the Fa1 powder into the beaker. That is something which you can do as well. Okay, and do take note of the requirement for such recording of mass. Okay, you need to record the mass of the empty weighing bottle, so that's 4.09 grams. Mass of the bottle with the Fa1 being weighed out, so that's 4.59, and then mass of weighing bottle with residual solid, that's 4.10. So usually you have a bit more. Of course, if you do the complete transfer, this will probably be 4.09 as well. Okay, and then the mass of Fa1, in this case the student used 0.49 grams. Okay, so do take note of the recording of such table, because in a real assessment setting, there will be marks allocated for that. Yep, and then for the titration, acidified Fa3 against Fa2. Fa3 is iron 2 solution. Okay, and then all the pipetting, I don't think you need me to go into details. In the review to practical 1, we have talked about what exactly is consistent results. Yeah, and of course for your recording, do take note of the appropriate level of precision. So for burettes will be 2 decimal place. Okay, and then if you take note of this particular table, we are looking at final burettes reading and initial burettes reading, not volume. So do take note of this. Some of you still make the mistake of writing burette volume. You can write out your title volume as well, and if you want to follow what you did in secondary school, your tick is fine as well. If you don't do that, it's also okay. Sometimes in a practical, we will give you additional instructions such as this. The reason why we gave you this additional instruction is really to ensure that the glass apparatus are kept as clean as possible, and it makes your washing I mean, it makes your washing later on more easily performed lah. Yeah, so for in our case here, because the KMNO4 is in the burette, so we want you to wash it as quickly as possible, so that it will not be stained with the purple KMNO4. Yeah, and of course not just to wash it with water, but also to wash it with iron too, because it's actually easier to use iron to wash away the permanganate. And then after washing it, do remember to flush it with copious amount of tap water. I always emphasize this in the laboratory. You flush your glassware with tap water, not deionized water. Yeah, the deionized water part, if you wish to do that, you can do that towards the end. Not keep using the deionized water, because you'll be wasting precious resources. Yep. There's also something for you to think about. Since the permanganate is intense purple and it's very difficult to read them off the burette, why do we want to put the potassium permanganate in the burette? Why not why not pipette potassium permanganate and put it into the conical flask, and then we titrate with iron 2 from the burette? Yeah, so that's something you can think about lah. That means why not we reverse the placement of the chemicals. Instead of permanganate into the burette, why not permanganate, we pipette it out, and then we titrate using iron 2 in the burette. Yeah, that's something you can think about. We probably will not address it in this review. Okay, yeah, then for B2 is standard calculation. So you just take your title value, so that's 26.765 for the average, and then just show the calculation, and that's it. Yeah, so this is relatively straightforward, so I don't think it needs any elaboration. C1 onwards, the calculation tends to the students tends to make some mistakes, so do take note of what you need to follow through. Okay, so for C part 1, you're required to calculate the amount of permanganate ions reacted in the titration. Okay, so the first thing you probably need to do, right, is to calculate the amount of permanganate in your volumetric flask. Yeah, so the student was quite explicit here. Number of moles of permanganate in 250 cubic centimeters of Fa2. That is in the standard flask. Yeah, so essentially what you do here is you go back to take the amounts which you have weighed out. So that's 0.49 grams. Okay, and then you divide it by the relative formula mass or relative molecular mass, depends on how you want to call it, because KMNO4 is actually ionic compound, so it should be relative formula mass. Yeah, usually in practical you do not have access to your data booklets, so if we need you to calculate any MR, we will give you the data. So just take note that all these data will be provided for you. So 39.1 plus 59.9 is Mn, and then oxygen, remember to multiply by 4. Okay, and then usually for intermediate step, we leave our answers to 4 or 5 SF. I think 4 SF is good enough. If you want to leave to 5, that's fine, but do not write a string of numbers. Okay, and you are also recommended to write your answer in standard forms. So this might be better represented as 3.101 times 10 to the power of minus 3 moles. Okay, yeah, but if you choose to write the 0 out, it's fine as well. Okay, and then after that you have to do the appropriate scaling, because the volume of Fa2 used was 26.65 cubic centimeters. Yep, so over here you find the number of moles in 1 cubic centimeters, and then you scale it up to 26.65, and then you will end up with 3.31 times 10 to the power minus 4. So it's better to write your answer in standard forms. That's easier to read as well. Okay, moles. Okay, and then based on this, you will move on to parts 2. You are required to calculate the amount of iron 2 present in 10.0 cubic centimeters of Fa3. That is actually the volume which you have pipetted out. So that's 10.0 cubic centimeters of Fa3. Okay, and then if you recall earlier on, I emphasized that the stoichiometric ratio was given to you. That's 5:1. Yep. So because the stoichiometric ratio is given to you, what you can do here is you can simply just multiply by 5. Okay, yeah, so you just multiply by 5, and then you get 1.65 times 10 to the power of minus 3 moles of iron 2. Yeah, so this is present in 10 cubic centimeters. Yeah, because remember this, 26.65 cubic centimeters is the title volume, and that reacts exactly with 10.0 cubic centimeters of Fa3. Yeah, so just take note of the way you do your calculation and the logic behind that. Okay, and then you're supposed to calculate the concentration of iron sulfate .7H2O in Fa3, both in moles per dm cube and in grams per dm cube. Okay, so what you do now is you can simply just take this value, because this is present in 10 cubic centimeters, and then you scale it to 1000. Okay, so essentially you're multiplying by a factor of 100. And then if you do that, then you will get 0.165 moles per dm cube, thereabouts. Okay, then after that, what you can do is you can convert it to concentration in grams per dm cubed. Okay, so what you do is, this is the number of moles, okay, in 1 dm cube of water. Yep, and then just multiply by the relative formula mass. Okay, that is FeSO4. Remember the 7H2O in as well. So some of you left that out. So remember to have the iron, the sulfur, and then 4 oxygen, and then 7 water molecules. Yeah, so if you do that, you should get about 46-ish grams per dm cube. Yeah, so remember to write your answers here as well. Yeah, and not just write it in the empty space. Okay. Okay, we'll move on to part D, that is the qualitative parts. The question asks you to suggest why it is not necessary to measure the volume of Fa4 with a pipette or burette in step 3 of B1. So if you cannot recall step 3 of B part 1, let us go back to it. Okay, you're supposed to use an appropriate measuring cylinder, transfer 10 cubic centimeters of Fa4. So you notice that they did not ask you to use a burette or pipette. So why is that the case? Okay, so let us go back to the questions. Yeah, so this is the remark I wrote. Excess H plus is used. Yeah, so earlier on I think we mentioned that we use excess sulfuric acid to provide an acidifying medium. Yeah, so because it is used in excess, its precise volume or accurate volume is not necessary. Yeah, so you can just give an answer related to that. That will be more than sufficient. Yeah, so there isn't any other types of answers that we will likely to accept here. Yeah, for example, I think this student mentioned about the calculation is not used, but I think it is not related, because the emphasis here is on the fact that it is being used in excess as an acidifying medium. So that will be the key idea that you need to mention. Okay, then for part E, the student prepared Fa2 but did not transfer all the washing, okay, into the standard flask before topping up with deionized water. Yeah, so again, when you pour your the contents in the beaker into the standard flask, sometimes the students may accidentally leave some drops of concentrated KMnO4 around. So what is that going to happen? Yeah, I mean, pretty much nothing's going to happen, but the actual concentration will be lower than expected. Okay, because you are transferring less amounts of KMnO4. Okay, so a lower concentration will mean that you will need a greater volume to complete the redox reaction with iron 2. So therefore, the titer value will be higher than expected. Yeah, so this is the link that you need to provide in your answer. So either you say that the total amount of KMnO4 in the burettes is lower than expected, that leads to a lower than expected concentration, and because of that, I will need a larger volume of KMnO4 from the standard flask in order to have a complete redox reaction with the iron 2. Yeah, so something along those lines will work. Right, then for part F, explain how the titer in B1 will be affected if hydrochloric acid was used instead of sulfuric acid. Yeah, so the answer to this is actually given right at the beginning. I think over here, I think I saw it somewhere regarding the, yeah, over here. So sulfuric acid is used if hydrochloric acid is used, it will react with permanganate to give chlorine gas. Yeah, so if it reacts with permanganate to give chlorine gas, that means that some of the permanganate that you have added will be reacted with HCl. So that means that I will need a greater amount of permanganate to completely react with the iron 2 in the system. Yeah, so with that logic, I will need a higher than expected amount of permanganate to react with the iron 2 in the medium. Yeah, so therefore my titer value will be larger than expected. Okay, so this is quite important, how you show the link of your thought process when you're answering this kind of 1 mark or 2 marks kind of question. Yeah, usually for assessment purposes, such question is usually worth about 1 mark or 2. Yep. And then for part G is the one that a lot of you made very careless mistake in. Okay, so maybe I will highlight some of the key details. Yep. The teacher performed the same experiment using 0.6 grams of Fa1. So the mass is 0.6. The titer value is 23.85. So these are 2 important data. Okay. The balanced total error is plus minus 0.1 grams. So let me highlight in pink. The titer value is 23.85, so that is related to the burette, so I'm going to highlight this in pink as well. Okay, so because of that, when you calculate your percentage error, yeah, you have to do them individually. So first of all, right, you need to calculate the percentage error of the mass. So that's plus minus 0.01 divided by 0.06, so you will get a number which is about 1.67%. Okay, and then for the burettes, do ensure that you read off your burette twice, right? Every time when you read off the burette, you do it twice. So that's 0.05 per reading. So you do it twice, so that will be 0.01. So 0.10 divide by 23.85. Okay, so this 5 is not very clear. Okay, so maybe just this is 23.85. Okay, remember that you have to read off your burette twice, so you need to multiply 0.05 by 2, so that's 0.10. Okay, and the titer value the titer volume has already been given, that is 23.85, so do not use your own titer volume. Yeah, some of you use your own, which is like 26-ish, 27. Yep. And then for the rest, what about the standard flask? So that's the error is 0.15. So what is the total volume in the standard flask? That's 250, so that's 0.15 divided by 250 times 100%. Okay, what about the pipettes? The error of the pipette is 0.1, and then you are pipetting out 10 cubic centimeters, so just make sure that it's 0.1 divided by 10.0 times 100%. Okay, so you total all the errors, so 1.67 plus 0.06 plus 1 plus 0.42, so you get 3.15%. Yeah, so just make sure that you sum up all the errors. Okay, yeah, so I hope the review of the practical will help you, will better help you in your learning. And there is also, I have also attached the link to the video showing the permanganate iron 2 titration in the link below. So if you want to just revisit the technique that you should be employed in your titration, just make sure you visit the video.